classes. This is section 4.1, composition of functions, and this
College
is
algebra.
college algebra. So, real quickly, when you can, with numbers, you can add, multiply, subtract, and divide them. You can do that with functions as well. For instance, if f of x equals 2x and g of x equals 3x, what's f plus g? 5x. And it turns out you can also compose functions, which you can't do that with numbers. So this is going to be an interesting new skill we're going to learn. So I'll do that right now. Okay, so we're given these two functions, composed of two functions, f of x equals x plus 3 and g of x equals the square root of x. This is the notation it looks like. So we're going to compose those two functions. So when you see it like that, it reads f circle g of x. So let's compose them, and that's defined as this f of g of x. So that's just helpful to do it. Change this form into its equivalent form. It's just more friendly notation. So notice the first function goes on the outside, and the second function always goes on the inside. And you should always have an even number parentheses, and I forgot the one more parenthesis. Okay, so that looks good. So it's only like 3 steps, so it's not that hard to do. So let's compose f circle g. So first step, go to there, and now the next step, rewrite that outside letter f, and then instead of writing g of x, we know what g of x is. It's the square root of x. So I'll write that. So notice we're advancing the ball there. Only one more step to go now. We've done this before. Evaluate a function. So notice for all x's in the f function, I'm going to plug in the square root of x. So for that x there, I'm going to plug in the square root of x, and I got to preserve that plus 3. And we get this for the final answer. The square root of x plus 3. Make sure you write that plus 3 not underneath the square root side. Okay, so that's the answer. We can reverse the order. How about what is g circle f of x going to equal? Well, it turns out you can just go like this, like you did before. G of f of x. So again, the second function goes on the inside. And what is this going to equal? Again, it's only 3 steps. I'm going to rewrite that outside letter g. What is f of x? We're told that is x plus 3. So we have that. And only one more step to go. And by the way, we're going to find out, when you compose functions, is it commutative? Will f circle g equal g circle f? In other words, when we do this, are we going to get that answer? We'll find out. Like notice addition is commutative. 2 plus 3 equals 3 plus 2. Subtraction is not commutative. 3 minus 2 does not equal 2 minus 3. And now we're going to see if composing functions is commutative. So what is this going to equal now? All we're going to do is plug in x plus 3 for all x's in the g function. So there's the g function. So I got to preserve the square root sign, and I'm going to plug in the whole thing, x plus 3 for that x. So we get this. And notice they are not the same answers. So composing functions is not commutative. Let's try another example. How about, let's let f of x equal, say, x plus 3. And let's let g of x equal x minus 3. These are interesting functions. They're inverses of each other. And it's very interesting when you compose inverse functions. A very interesting result happens. I'm going to write this down as a matter of fact. When you compose two functions which are inverses of each other, so when you compose inverse functions, then the initial input will always equal the final output. So that's very cool. And you can tell these are inverses of each other. In real life, what are some examples of inverses? How about if you drink a lot of water, and then what do you have to do next? Go number one. So notice they kind of undo each other. What's the inverse operation of, say, driving a car? In drive, the inverse would be reverse. So notice they undo each other. That's the idea of inverses. So, and you can tell these kind of look like they might be inverses of each other. So let's see what happens. Let's try f circle g of x. And what is that going to equal? First, I'm going to do this nice little trick here. Rewrite it in more friendly notation. The second function goes on the inside. And now it's only two more steps, I think. So we go f of, what is g of x? X minus 3 equals, and now one more step to go. What does this equal? Plug in x minus 3 for all x's in the f function. And there's the f function. So what am I going to plug in for that x? X minus 3. So I'm going to write x minus 3 and then preserve that plus 3. And always simplify if you can your answer. And doesn't that just equal x? And isn't that idea right here, didn't that hold true? Because if you look at f circle g of x, that's the input there, that x. And so that's the initial input, and doesn't that equal the final outputs? So that will always happen with inverse functions when you compose them. Let's do, and it's interesting, when you can change the order, g circle f, and it will be commutative if they're inverses of each other. If f and g are inverses, then it will be commutative, because if they're inverse functions, it doesn't matter what order you do it in. The initial input will always equal the final output. Let's do, how about g circle f, instead of doing the generic x, and if I did the generic x, we would get x for the final answer, but let's be a little different here. Let's let our input be a number, any real number. How about 7? Or let's make it, I think this is going to be a better choice, although 7 would work. Let's try, well, let's do 7, what the heck. Okay, so we have that. So what is that going to equal? Here's the first step. G of f of 7, not x, but 7. So that's the first step. Again, the second function goes on the inside. And notice the input is not the generic x, but the number 7. Okay, what is this going to equal? I've got a feeling the final answer is going to be that initial input, 7. Let's see what happens here. So, next step, what is that going to equal? G of, don't write f of 7, that's not advancing the ball at all. What is f of 7? Where's f of x? Right here. What's 7 plus 3? 10? So, isn't f of 7 going to be 10? Again, f of 7 is, what's f of 7? 7, plug in 7 for all x's. 7 plus 3 is 10. So f of 7 is 10. So we have this. And then what does that equal? Plug in 10 for all x's in the g function. And here's the g function. What does 10 minus 3 equal to? 7. Surprise, surprise. Notice the initial input equals the final output. There's something very therapeutic and cool about that idea. Let's see, anything else? So that's the whole idea of composing functions. It's very straightforward. You just do those steps. Let's see, this was, here is another one in the notes that I put on Learn. Show that f circle g of x equals the reverse order, g circle f of x. So notice it's commutative if you're talking about inverse functions. The initial input here is x, as well as here's the initial input is x. And notice they'll both equal that x, because f and g are inverses of each other. This one's harder to tell by observation. Unlike that last example I did, it was pretty obvious. But, you know, you can kind of tell the 2's multiplying with the 6 here. Now you got a 1/2 times it. Here's a minus 6. Here's a plus 6. So they are inverses of each other. And, you know, if you're not sure they're inverses of each other, compose them and see if the initial input equals the final output. If it does, it's inverse function. So that's good for you to try on your own. Here's your two functions, and compose f circle g of x. Or you can do f circle g of 4. And the initial input should equal the final output. Okay, let's see, this example here, let's make sure we understand this example. This is a cool one. It's a graph. What is g of f of negative 1? What is f of negative 1? Go to the graph, the f graph, and notice that point is on the graph, negative 1, 3. So when x is negative 1, isn't the output 3? So that becomes g of 3, which we have right here. G of 3. And what does g of 3 equal? Well, go to the g graph. Notice this point is on the g graph. When x is 3, apparently the output is 4, and that's the final answer. This was a quiz I would have given ordinarily in class. I'm sure you all would have made mincemeat out of it. But you don't have to do that quiz. You've got enough work to do with my math lab. All right, ladies and gentlemen, it was fun, and good luck, and goodbye.